Okay, so welcome back. This is the second video in a series of lectures covering dynamic optimization. I believe this is chapter 7 in the Monetary Economics on NyQuil textbook. Now, in this chapter, let me make sure this camera is level. Level enough, I'm good. So, in this chapter, we're discussing dynamic optimization, how we're optimizing, how we're ultimately really maximizing utility over some time horizon, right? Making it dynamic. So, if you remember from last time, I set up the utility function where utility ran a certain number of time periods and I wanted the sum of lifetime utility. So I wanted the sum of utility today, utility tomorrow, utility 2 days from today, 3 days, so on and so forth. And the utility function that I was using, the functional form for utility, was log utility, or the natural log of consumption. But I had to make sure that my preferences for the future were included in this. So the way I did that was I introduced beta, which is this discount factor. And beta tells me basically how much I care about the future relative to how much I care about today. So if beta is 0.95, tomorrow is 95% as important to me as today is. And then as time went on, I've got this exponent t that forces beta to get smaller and smaller and smaller. But with the discount factor, remember the discount factor was a function of the discount rate. This discount rate, which is rho, it's not a p, it's a rho, tells me how impatient I am. So the more impatient I get, the smaller beta gets. And as beta gets smaller, then I care less about the future relative to today. But we're talking about optimization. We're talking about maximizing utility over the agent's lifetime subject to a budget constraint. How are we going to do that if the natural log of consumption, or the natural log, we'll just say natural log of x, has no maximum? It just keeps increasing. It's increasing everywhere. It's increasing in concave, but it is still increasing everywhere. And there's a problem with that because, well, it means that there's no maximum. So what are we going to do? Well, on its own, we can't maximize this sucker. But what we can do is if we introduce a constraint, that can allow us to find a maximum for this thing. And what is the constraint? Well, if you remember the homework where I had the utility maximization problem and the budget constraint in there, I had income equals the price of x times x plus the price of y times y. Basically, income being equal to what I spend on those two goods. So if income is equal to what I spend on those two goods, then what that basically tells me is in this constraint, the source of funds must be equal to the use of funds. The source of funds is income. The use of funds is stuff I spend my income on. All right, so what I make can't be exceeded by what I spend. Now, in a static sense, that's like you make $800 a month, then all you can spend is $800. But there's a little bit more to it than that. And before we get that far into the weeds, let's look at what this constraint is going to be. Because when we see what the constraint's going to be, it's going to be a little bit easier to follow when talking about this stuff I spend income on and how I could actually theoretically spend more than what I'm earning. Because, well, I don't want to confuse you and keep you confused for a while, so I'll just like totally ruin the end of the movie for you, like M. Night Shyamalan twist type thing. Surprise, surprise, Bruce Willis is dead the entire time. If this is intertemporal, if this goes over time, and my income stream is going to be relatively constant or growing, or at least I expect it to be relatively constant or growing, I can spend a little bit more now than what I earn now, and then consume a little bit less in the future to basically save it to pay back what I borrowed in the past. Right? That's the beauty of this intertemporal component to this stuff. So how is that going to work? Well, it's going to work by implying we need an intertemporal budget constraint. And it begins with this thing right here, which is our resource constraint. Now this might look kind of familiar to you. It's basically GDP, gross domestic product. If you remember, GDP is equal to consumption plus investment plus government expenditures plus net exports. Well, there's no government. And I'll explain why a little bit later. There's no government in this model. Got him, I think. So there's no government in this model, there's no government expenditures to have to worry about. If there's no government expenditures, there's no point in having that little G term in this. It's also a closed economy. Which means net exports are zero. So if net exports are zero, we have no trade, right? There's no imports, there's no exports. So anything that's being produced in this country is being sold only in this country. And because of that, investment is equal to savings. So I can either consume or I can invest. If I'm investing, I'm saving. So I can either consume or save. So I'm just going to, for now, say this IT, investment, is equal to ST, which is savings. Because whatever I'm not consuming, whatever I'm not spending on consumer goods, like fancy guitars, fancy amplifiers, cat food, cat litter is, oh my god, cat litter a mess when you have 4 cats. Whatever I'm not spending on that stuff, I'm saving. And whatever I'm going to choose to save is dependent on 2 things. One, my preferences, the discount factor and the discount rate. Right, rho is going to determine the savings behavior based on my preferences, right? What do I want? What do I personally want to be spending on consumption? But this stuff right here, from here to here, is all my personal preferences, right? These are all my feelings. What I'm getting to here is more on what's going on with the market. How is the market working? Because I can have feelings all day. I can have feelings all I want and go, I want to consume a bunch of stuff. Or I want to save all the time. But we're not special, right? Nobody really cares about us. The market doesn't care about us. The market just wants to work. And we're not getting into the moral or ethical debates about this stuff because that's not what we do in economics. It's not what this course is about. This course is about learning how these models work. So, if investment is equal to savings, I can rewrite the constraint as the following. Like that. So if I rewrite the constraint like that, well, this says that I can either consume or I can save. Which is good. That's cool. We have something that we can work with here now. Because why would I have any incentive to save? Well, there'd be my preferences on whether I want to save or not. But there's one other component, and that other component is the interest rate. If I lend one of you money, and I say you can borrow it for a month, well, that'll probably help you out over that month, right? Maybe you need the money, maybe there's, something that you have to buy, and there's kind of a time limit on when you can buy it, and it's no longer available in a month when you'll have the money, and so you'd rather have it now, which is fine. That's totally okay. But the issue is, if I lend you that money, I go a month without that money. I go a month having to plan out a little bit more frugally how I'm going to survive. I need to plan out what my consumption pattern is going to be a little bit differently, right? And that's putting an imposition on me. It's inconveniencing me to an extent. And I don't mind being inconvenienced. Sometimes it's good. Sometimes it's nice to be helpful to your friends and let your friends borrow some money. But you're still getting inconvenienced. So when it comes to being inconvenienced by lending out all this money to somebody, well, you should probably be compensated for that. How am I going to be compensated for that? Well, probably with a little bit of interest. So let's say if I save ST today, I'll get the principal of the loan back, which was ST. Plus the interest on that principal. Which is the interest rate R times how much I lent out. So RT is the real interest rate. And we'll just kindly assume for the moment that the real interest rate is going to be between 0 and 1. Now, it's not always the case, but here for the argument in this model, we'll just go ahead and say it's between 0 and 1. So you could have an interest rate of 0 if interest rate was somewhere between 0 and 1, like say a 5% interest rate. R2 would be 0.05. So if I lend out $100, I lend out $100 and the interest rate is 5%, then tomorrow what I'll get back is my principal, $100, plus the interest rate times what I lent out. So I get $100 plus 0.05 times 100. Gives me $100, which is my principal, plus $5, which is the interest, so I get $105 back. So that interest rate is inducing me to want to save more. All right, so this is the stuff that's going on in my head. This is how much I care about the future. And we're going to see there's a balancing act between this discount rate, the measure of how impatient I am. There's a balancing act between that and the market interest rate, right? I'm sure some of you at this point have heard that funny phrase or saying that facts don't care about your feelings, right? Well, what's going on with this utility function is this utility function says feelings don't really care about your facts. This is what I want. Me. I. My feelings. What I want. What's going on here is facts don't care about your feelings. Right? This constraint doesn't have your utility in it. This constraint has a term in it that enters into your utility. Right? But this constraint is not dependent on how you feel. Feelings don't care about your facts. Facts don't care about your feelings. There's a balancing act between the two. There's a balancing act between what we want personally and what the market is willing to offer us. What we want personally is rho, right? Well, rho is determining what we want personally. The interest rate, though, is what the market's going to give us. So if we balance that out, we can find an optimal path of consumption and saving over time. We just have to figure out how we're going to do that. So how are we going to do that? Well, I'm going to start by erasing this board. So here's what I am going to get. So I had, as I showed you before, constraint for today is yt equals ct plus st. But that's today's constraint. Right? If I'm saving, then what I don't consume today gets saved. I can't use it. If I save today, I can't use it until tomorrow. But I'm I'm going to be able to use it tomorrow. So how do I show there's a way that I can use this tomorrow? How is that going to work? Well, how can we see what's available for tomorrow? How are we going to do that? So I only got the constraint for today. So I can't see what's available for tomorrow. I can take a wild guess that it's probably going to be what my income was today, plus whatever it was I saved today. So the source of funds for tomorrow will be tomorrow's income plus what I saved today plus the return on what I saved today. So what I have available to spend tomorrow plus what I saved yesterday plus the return on what I saved yesterday. How do I write that out? Well, let's look at my income. What's my income tomorrow going to be? Well, my income tomorrow is going to be yt plus 1. Right? Because income is y. Tomorrow is, well, today plus one more day. Yt plus 1. Right? Plus what I saved yesterday. So what did I save yesterday? Well, I saved s sub t yesterday. Alright, that's what I saved. So I got my income, which we're treating as exogenous right now, plus what I saved, which is s, from yesterday. Right, because if I can't spend this today, it moves over to tomorrow. So when it moves over to tomorrow, well, I have st, not st plus 1. Because what's available for me to spend today, on top of my income, is what I had saved yesterday, right? You let someone borrow $100 today, you get it back tomorrow. So tomorrow your income is your income plus that $100 that you get back as the principal for what you let somebody borrow the day before. Right, but you needed that incentive to be able to lend out that money to that person. I really need to say those resources to that person because there is no money in this model. How do I know there's no money in the model? Well, there's no variable for money. So we can think of this more as resources, right, as just raw income. So a little tough to get your head around, I'll admit. When we add money in, you'll kind of see how things change a little bit and how the interpretation can change. But it's nice and easy to start simple with this, understand the model in its base form, and then add money into it. Give me just 1 second here. Check my phone. Okay, wanted to check my emails on something. So, anyways, income plus what I saved yesterday, but remember there's also the return on what I saved yesterday, which is the interest rate times what I saved. So this is my source of funds. Let's look at our use of funds. Well, what's my use of funds going to be tomorrow? Well, I can consume stuff tomorrow, CT plus 1, right? Consumption 1 day after the initial period, which was just T. So T plus 1 means consumption tomorrow. And I can save ST plus 1. This is my use of funds. So source of funds still equals use of funds. So if I can lend that money out to somebody, right, where S gets lent out, well, we can also think on the flip side of that. If I lend that money out to somebody, somebody else is going to borrow it, right? So if somebody else borrows it, for that period, they're actually spending more than what they earned. But next period, they can't spend more than what they earned because they have to pay back what they borrowed in the first period. So if we have positive savings, right, that means we can't really consume as much as we wanted to. If we have negative savings, if we're dissaving, we're borrowing. And if we're borrowing, well, that allows us to essentially have more resources at our disposal this period, but we got to pay it back. So in the event that we borrow, right, the source of funds at YT plus 1 is not going to be plus ST plus RT times ST. It's going to be minus this sum here, which means I can't consume as much tomorrow. So if I want to consume more today by borrowing, I have to consume a lot less tomorrow by paying back what I borrowed in the first period. So this is how we can actually have a balanced budget constraint where we spend more than what we're actually earning. Because we don't care if the budget constraint is balanced every period. Rather, we care that the budget constraint is balanced over the course of the lifetime. So let me write that out. So if I dissave, if I dissave, I can spend more today, but I got to pay it back by paying back more tomorrow. I got to pay what I borrowed, the principal, plus the interest on that principal. If I save, then I can't spend as much today. But I've got more at my disposal tomorrow. Right? What would be an instance where we would be dissaving? Well, if you're in college, you're probably, at least a good number of you are taking out student loans. Right? So you're spending more than what your current income is. But you're doing that because you're making an investment in your own human capital. If you're making an investment in your human capital, you're choosing to save, or well, dissave today because you expect your future income to be higher. Therefore, borrowing today will actually pay off tomorrow. Even though you got to pay back those student loans, you'll be making more money than if you didn't go to college. So that would be why you would want to dissave. Or that would be why you want to borrow rather than save. On the other hand, if you save, well, you got to be a little frugal today. You can't spend as much today, but you'll have more at your disposal tomorrow. So let's think we're no longer in our late teens and early 20s, or for me, early 30s. And instead, we're in our late 60s, early 70s, and retirement's probably around the corner. We're going like, yeah, I think I'm done working. I think I'm done being bitched at, being told what to do. So you just go up to your boss, tell him to take that job and shove it. Great song, by the way. So, well, how are you going to do that, right? How are you just going to be able to go, I don't feel like working anymore? Well, you've probably been saving over a good chunk of your career. So you've been saving your income, you've been storing part of your income away in order to be able to use it later. Like when you retire and you no longer have a source of income, well, you've got all this money stashed away that now you can use. So you got more at your disposal in the future because you saved today. And again, it comes down to a balancing act between the rho, the discount rate, and the interest rate, R. If we can find a nice, happy balance, happy medium between those two variables, really, we probably need to call them parameters, to be honest with you, because they're exogenous. If we can find a happy medium between these two exogenous parameters, then there's probably going to be some kind of a dynamic equilibrium going on. Hopefully this is starting to make a little bit of sense as to why I taught you dynamics and fixed points with like steady states. A steady state was a dynamic equilibrium. We're looking for a dynamic equilibrium here. We're looking for an equilibrium optimal consumption path over time. But this goes on and on and on, right? Every single period, whatever I don't spend today, I get more tomorrow to be able to spend, right? So let's update this guy one more period. Let's update that one period. All right, well, what I'm going to do is I'm going to have yt plus 2, because now we're looking 2 days into the future, plus what I saved from the first period, plus I'm going to repeat what happened here for the second period. So the principal that I lent out in period 1 plus the return on that, so my investment plus the return on my investment, but then I also have my savings or my investment from the second period plus the return on investment from that second period. And that will be equal to CT plus 2, because remember we're 2 periods in the future now, plus ST plus 2. All right, and if I wanted to take it one step further, I could have YT plus 3, and I would have this from the first period, this from the second period, plus ST plus 2, plus RT plus 2 times ST plus 2, equals CT plus 3 plus ST plus 3. Now, if this is a finite horizon, it's a finite horizon, then there's going to be a last period, and time will cease to exist after that last period. We have no reason to save anymore. Why don't we have any reason to save in that period? Well, time won't exist in that next period. If there's an asteroid coming to hit Earth, right, your savings will probably just become zero. Why? What's the point? You won't be able to use it. So if you can't use it in the future, why are you going to save it? That's dumb. That is not optimal economic thinking. You're not going to save if you and the rest of time is not going to exist after that last period. So savings in that last period is always going to be zero. So let's erase this again. And I'll show you two little things. I'll make one assumption about the time horizon, make it easy. And then I'll show you a way to write savings plus the return on savings in a more compact way, and something that's a little bit easier. First thing we're going to do is assume a two-period model. So the universe exists today, the universe exists tomorrow, and the universe ceases to exist. So because this is a two-period model, we will have two constraints. The first constraint, y equals c plus s. All right, that's the constraint that the agent faces today. The second constraint is this. This is the second constraint that we face. Now the second period is the terminal period. There is no third period here. It's just period 1, period 2. So if there's no third period, period 3 just doesn't exist. What does that imply about next period savings, st plus 1? What do we think st plus 1 will be equal to? Well, if you thought it was 0, you are absolutely correct. Right? Because remember, utility is increasing in consumption. The more we consume, the higher our utility. Now, we may choose to save because of our time preferences. We may opt to save today to be able to consume more tomorrow, which is determined by beta and rho. And utility is not increasing in savings. Right? Savings would actually decrease utility. So the more we save, the less we consume, the lower our utility of consumption. So consumption's at the heart of this entire matter. So the only reason I would be willing to lower my consumption today by consuming less, lower my utility by consuming less, is because I expect to have higher utility tomorrow because the future matters a little bit more to me. So if I expect higher utility tomorrow, by saving a little bit today and consuming more tomorrow, then I have every incentive to save. But if I won't be consuming anything tomorrow because I won't exist tomorrow, I have no incentive to save. And because savings decreases my utility of consumption, no reason to save, so you don't save. St plus 1 equals 0. So let's rewrite out these constraints now. Now I'm rewriting both of them for completeness. I'm very OCD like that, and it just makes sense to keep everything as complete as possible here. I get this. So these are my two constraints. So that was the first thing I said I was going to do. We were going to assume a 2-period model. So the universe exists for 2 periods. The second period, right after the universe ceases to exist, so I have no incentive to save. So St plus 1, which is here, is equal to 0. So I literally consume everything. I consume all of my income, all of my sources of funds in the last period. So in the last period, I consume all sources of funds. All right, if you know that you are going to die very shortly, you're probably going to stop saving and instead just spend everything you got, because who cares? And there are plenty of movies that have that, plenty of TV shows, funny little subplots. Star Trek Deep Space Nine had a great one where one of the aliens, he's a Ferengi, his name's Quark, thinks that he's got this terminal illness and he's going to die, so he auctions off all of his body parts so he can basically spend everything he's got now and enjoy the last, little bit of his life. And then it turns out, oops, he's actually not going to die. Now he's got to pay back everybody for all of his organs that he auctioned off. Kind of a sick episode, but Deep Space Nine is always pretty dark to begin with. But that would be the logic here. That would be explaining what's going on with that particular set of assumptions in the model. Now, the next thing that I wanted to do was show you a more compact way to write this. How do we write that in a nicer way? Well, I got that. St plus RT times St. Is there something in there that shows up in both terms inside those parentheses? The answer is yes, it's savings, St. So let's factor out savings. What I get is this, 1 plus R times S. So if you were to distribute S through what's inside these parentheses, you would get St plus RT times St. This is a lot nicer to write than this is. Way nicer. Right? So let's rewrite the budget constraints again. Well, the first period's constraint is still the same, yt equals ct plus st. The second constraint is that yt plus 1 plus 1 plus rt times st equals ct plus 1. I'm not super happy with how I wrote that. It looks a little sloppy, and it's very important that my writing is as legible as humanly possible. So let me rewrite that. So we have that. These are our two constraints. So with these two constraints, this is going to wrap up this particular section on explaining the constraint in a model with exogenous output. So that will conclude this lecture. There's another one coming immediately after this.